Okay, welcome to another tutorial on percentage atom economy. So I know it is very straightforward to calculate percentage atom economy, and the equation for it is given in the data book. Okay, so over here you can see the equation for percentage atom economy. So it's simply the molar mass of the desired product divided by the molar mass of all reactants multiplied by 100 because it's a percentage. Now, we know how to calculate atom economy for single step reactions. So just a single, reactants equals products. Like we know how to do that, but we don't know how to do it for a multi-step process. Think about a reaction pathway. Okay, for example, let's say we've got this molecule A is converted into this molecule B, and then this molecule B is converted into molecule C. We haven't really discussed how to calculate the percentage atom economy for this entire process. Okay. The formula holds true though. You still use the same formula as given in the data book. The molar mass of desired product divided by the molar mass of all reactants. The key word here is all. And how do we define all reactants? So let's look at an example question to help us understand this a little bit better. Okay, so the question is, okay, imagine the Haber-Bosch process. Yeah, we've talked about this quite a bit already. So the Haber-Bosch process converts H2 and N2 into NH3. The H2 gas can be produced from the steam methane reforming process. The two reactions for the overall process are shown below. So here they are. Okay, so there's two steps. Step one is where methane is reacted with steam to form carbon monoxide and hydrogen gas. And step two is you take this hydrogen gas, you take the hydrogen gas that you made in the first step, and you use that in the second step. Okay, you react it with nitrogen to produce NH3. So the question is calculate the percentage atom economy for the overall pathway. Now to do this, we need our equation. So percentage atom economy is equal to the molar mass of desired product divided by the molar mass of all reactants multiplied by 100. Now let's look at this process here. Our desired product is simple. Okay, we can easily identify the desired product. This is our desired product. Okay, and so we can easily calculate the molar mass of that. Okay, now key things to remember here. Okay, so let's write down some key rules. Okay, key rules. Rule number one is factor in coefficients. Factor in coefficients. In other words, take them into account. Okay, so if it says 2NH3, that means we need to have 2 times the molar mass of NH3. Okay, divided by the molar mass of all reactants. Now, the reactants are CH4, okay, because we used CH4 at the beginning. We also reacted water, all right. Carbon monoxide is not a reactant, it is a product, okay, and we don't even carry this on to the next step. Now, we do carry on the H2 to the next step, okay. So this H2 here, we do carry it on to, it is a reactant, okay, the H2 is a reactant. Let's just circle the reactant one. But, okay, the atoms that the H2 came from is from the CH4 and the H2O, which we already accounted for. Okay, so what we say is that this H2 is an intermediate. So I'm gonna do that in, let's say, purple. Okay, this H2, actually no, I'm gonna do it in a different color. Let's do it in green. Okay, this H2 is an intermediate. Intermediate compound, let's just say. Sorry, intermediate molecule. Okay, intermediate molecule. We must not factor in these intermediate molecules when we do our overall calculation, okay? Because the atoms that the H2 came from is from the CH4 and H2O. Those were the reactants that made up that were used to make the H2. So we count them. This H2, we don't double count it. Like if we counted it again, it's like you double counting, all right? So we're not going to factor that in, but we are going to factor, because another reactant we can see, another reactant is the N2. We needed this N2 to react with the H2, which we got from CH4 and H2O, to make the final product. Okay, so in blue, these are the reactants. These are what we mean by all reactants. All right. So let's put those into our equation. So we needed 1 CH4, molar mass of CH4, plus molar mass of H2O. And we've got, one of them, and we've got we've got 1 N2, that's right, plus molar mass of 1 N2. All right, and all of that is multiplied by 100. So let's do the math slowly. Skip ahead if you like. So 2 times by 17 divided by 16 plus 18 plus 28. Okay, and that is equal to, and just give me a moment while I calculate this. 16 plus 18 plus 28. So that's 54.8%. 54.8% atom economy. Okay, so some of the rules that are important to remember is factor in coefficients, and rule number 2 is disregard intermediates. I think I spelled it wrong before. Intermediates. Okay, disregard the intermediate molecules. Okay, because if you don't disregard them, then you're double counting atoms. Okay, and yeah, I think that pretty much explains it all. This is something that I really need you guys to watch and understand, because it wasn't mentioned in the textbook, and I haven't seen any kind of questions on it yet. So potentially they might ask it this time. All right. As always, if you have any questions, please feel free to send me an email.